Polar bears and polar cubs. It's time for balancing chemical equations. Let's talk the inventory way. The first or kind of simplest conceptual way to balance is inventory. So what you do is you make an inventory of your atoms on the reactant side. You make an inventory of your atoms on your product side, and then you multiply by whole numbers in order to make them equal. Now, when you multiply it, since we're talking about putting a coefficient in front of the entire compound, you have to multiply both the cation and anion by that number. Therefore, it may kind of lead you down a path, and that's kind of what we're going to talk about when we start balancing. So let's dive right in. Okay, so step one is you want to have subscripts can't be changed. We can only put coefficients. If the coefficient is 1, we don't write 1. And actually, on Polaris, we will put an N. Okay, and the reason that we're putting NN, okay, the reason that we'll put NN is that stands for not needed. Okay, now balancing each element one at a time, and then kind of following that element that's also in that compound. Starting with atoms that are combined within a compound first, then polyatomics. If they appear on both sides, you can keep them. We're going to keep H and O for last. And then remember that there are 7 elements that are known as diatomics, and those, they're not just one symbol. So that is H2, N2, O2, F2, Cl2, Br2, and I2. And that is, again, only by themselves. They can bond individually. So the first example that we're going to do, we're going to break it down. Okay. And then we have 2 N's. We have 2 H's on this side, and on the other side, we have 1 N, and we have 3 H's. Now, if I look at this, I notice that on the left-hand side, I have 2 N's, and on the right-hand side, I have 1 N. So what I would do is I would multiply this by 2, giving us 2 N's. However, since N and H are in the compound together, this needs multiplied by 2 as well, giving us 6 H's. Now that N's are balanced, now we got to focus on H's. We have 6 H's on the bottom. So what do we multiply 2 by to get to 6? And it's a 3. Now that we double check, N's are balanced, H's are balanced. All right, so we're going to put our coefficients in. So we put a 3 here and a 2 here. And we are balanced. I want you guys to kind of work through this one, and I will go ahead and I will show you the work for it in 3, 2, and 1. So with this one, if we create our inventory, we have 1 Na, 1 Cl, you have 2 Fs. Notice how I kind of keep columns for each compound. And then I have 1 Na, 1 F, and 2 Cls. So you might notice that, Fs and Cls are the ones that aren't balanced. So it doesn't matter which one you want to start with. If we start on the left-hand side, we have 1 Cl. So how do we make it 2? Well, we're going to multiply it by 2. That gives us 2 Cls. However, Na is also part of that compound, so you have to multiply it by 2 as well, giving you 2 Nas. What I like to see is, hey, now let's look at Nas on the product side. We only have 1, so we also need to get that to 2. And that gives us 2 Nas. We have to multiply the F by 2 because it is part of the same compound. giving us 2 Fs. Now let's take the Fs, go to the reactant side. We already have 2 Fs, and then we already have 2 Cls. And we're balanced. So we're going to put our coefficients. We're going to put a 2 here and a 2 there. Now, I'd like to give you guys one more before you start working on your worksheet. And that one is, I will write it out. It's going to be Ba barium hydroxide plus phosphoric acid, phosphoric acid. Okay, and that's going to go to barium phosphate plus water. Now, you're working through the inventory, and that's great. The inventory is a great beginning tool to help you on your way. I'm going to show you a little bit of a advanced technique. And the advanced technique that I like to use is that I find the compound that is considered the most complex. So to me, this is the most complex. You have a polyatomic, you have 2 of them, and you have 3 of your other ion. So I'm going to pick one of them, Ba or PO4. So I'm going to pick Ba. I have 3 Bas on this side, if you were doing inventory. And the reason I picked the most complex is I really want to keep this as a 1 coefficient. So if I have 3 Bas on the right-hand side and I only have 1 Ba on the reactant side, I'm going to put a 3 here, and that balances my Bas. Now, what also happens with this 3 is it goes to the OH. Well, currently you have 2 OHs, and on this side you have 1 OH. So after the 3 gets distributed, you have 6 on the left, so you need to have a 6 on the right. Well, now that you have 6 OHs on the right, we need to talk about H's. Well, you have 6 H's. On this side, they come in 3s. How do you make 6 from 3? You multiply it by 2. And last but not least, 2 now goes to the PO4. And if you look on the right-hand side, you have 2 PO4s. So it's kind of like a nice little circle where if you start with the most complex compound, when it's like this, it will actually lead you back to the other side of that same compound if done correctly. All right, that's been it. Go ahead and try worksheet number 1 and let me know if you have any